Hello friends, I welcome you in lecture number 37 on logic. In previous lecture, we have discussed about rules of inference for propositional logic, and we have also understood what is meaning of argument and argument form. And we also know that what is the meaning of valid argument. So if we recall, argument is a sequence of propositions in which last proposition is called conclusion and remaining propositions are called premises, and argument is valid whenever all the premises are true, implies that conclusion is also true. And we are going to discuss certain particular type of argument forms, and we are going to discuss that which type of argument forms are always valid, and using those argument forms we will be able to decide whether any given argument is valid or not. So those are known as rules of inferences for propositional logic, and if you recall, in previous lecture we have discussed one rule of inference and it is known as modus ponens. Another name is law of detachment. So what is modus ponens? Modus ponens says that if we have two propositions P and Q, and if P and P implies Q are true, then this implies that Q is also true. So this rule of inference is called modus ponens or law of detachment, and this is valid if an argument is valid if it can be written in this particular form. If our argument takes this form, then using modus ponens we can say that given argument is valid. In this lecture we are going to discuss another rule of inference which is known as hypothetical syllogism. Hypothetical syllogism. So here also we have particular type of argument form, and it is easy to remember that argument form also. Hypothetical syllogism requires three propositional variables P, Q and R, and it is similar to transitive property. If we have P implies Q and Q implies R, if these two are true, then P implies R. So this is another rule of inference, and it is known as hypothetical syllogism, and it says that whenever P implies Q and Q implies R are true, then P implies R is also true. So we are going to prove this rule of inference known as hypothetical syllogism using truth table. They have asked to prove this rule of hypothetical syllogism in GTU Winter 2024 exam. Here they have asked to prove that this argument form is valid using truth table, and now we know that this is hypothetical syllogism, and it is another important rule of inference which we are going to use in upcoming lectures to check the validity of argument. So we try to prove this argument form is valid using truth table, and if you remember, we have proved one argument form modus ponens in previous lecture, and whenever we are using truth table to prove that argument form is valid, we will first write down what are the propositional variables. Here we have three propositional variables, so we will have three columns for P, Q and R. We have two premises, so we will we will prepare the column for P to Q and Q to R, and conclusion is P implies R. So we have to prepare the column corresponding to P implies R also. After preparing the truth table, we will search for those rows in which P implies Q and Q implies R both are having truth value true, and then we will check the corresponding truth value of conclusion, which is P implies R. So if this happens, that whenever P implies Q and Q implies R are true, implies that P implies R is also true, and if it is valid, or if this happens in all those rows in which P2Q and Q2R are true, then we can say that argument form is valid. So it is easy to check the validity of given argument form using truth table, but if number of propositional variables become large, then this process becomes uncomfortable or tedious. So in that case, we can use rules of inferences, which we are going to discuss one by one, and we can use those rules of inferences to check whether given argument form is valid or not. So here first we prepare the truth table for this hypothetical syllogism. So I have already written all these columns here, and now first we write down all possible combinations for truth values of these three propositional variables. And if you recall, in earlier lectures we have written all these possible combinations in this way. Here 4 times F, then true, true, false, false, true, true, false, false, and for R we write alternately true and false, true, false, true and false. Now for P to Q, this is conditional statement, and we remember in this way that this conditional statement is false if P is true and Q is false. Whenever P is true and Q is false, then P to Q has truth value false. In all other cases, it has truth value true. So for P implies Q, we will concentrate here. Here P is true and Q is also true. Therefore P implies Q is true. Same thing here, P and Q both are true. In third row, P is true but Q is false. Therefore this is false. Here also same thing, false, because P is true and Q is false. And in last 4 rows, P is false. So we don't have to check anything. We will write directly truth value true. We have discussed all these things in the lecture series of logic and in the lectures of this logical connectives. Similarly, we can write the column for Q implies R. So for that we will concentrate on these 2 columns. Q implies R is false whenever Q is true and R is false. In all other cases, it is having truth value true. So in this first case, both are having truth value true. Therefore we write true here. Here Q is true and R is false. Therefore this is false. In these 2 cases, Q is false. So we don't have to worry about R. We can directly write true here. Here Q and R both are true. Therefore Q implies R is true. Here Q is true and R is false. Therefore this has truth value false. And here Q is false. Therefore we write truth value true. Now we write for P implies R, same thing. P implies R is false whenever P is true and Q is false. In all other cases, it is true. So in last 4 rows, P is false. So here we directly write down T. Then in the first row, P is true R is true, therefore truth value is true. In second case, P is true and R is false, therefore P implies R is false. Here P is true and R is true, therefore P implies R is true. Here P is true and R is false, therefore this is false. So we have prepared the truth table. Now what we want to check? We want to check whether this is valid or not. That is, whenever P implies Q and Q implies R, both are true, then P implies R is also true. So we will concentrate all those rows in which P implies Q and Q implies R, both are having truth value true. So here we can see in first row P implies Q and Q implies R, both are true in first row, and we can see that P implies R is also true. This means whenever P implies Q and Q implies R, both are true, then P implies R is also true, and we have to check for all possibilities of P implies Q and Q implies R in which both are true. So in first row both are true, in second row both are not true, in third row also, in fourth row also both are not true, and in fifth row both are having truth value true and corresponding value of P implies R is also true. Similarly in row number 7 both are true. So here also we can see P implies R is true. In 8th row also both are having truth value true and corresponding value of P implies R is also true. So what we have observed that whenever P implies Q and Q implies R are true, then P implies R is also true, and therefore this argument form is valid. So using truth table we can easily check the validity of given argument or argument form. So here I have written that both P implies Q and Q implies R have the truth value T in row number 1, 5, not 6. Here they are not having truth value true. In 6th row this is true and this is false. So in row number 1, 5, 7 and 8, P implies Q and Q implies R have the truth value true, and P implies R also has the truth value T in all these rows 1, 5, 7 and 8. That is what we have discussed. In first row these two are having truth value true and P implies R is also true, and same thing for this row number 5, 7 and 8. So this means P implies R is true whenever P implies Q and Q implies R both are true, and therefore given argument form is valid. So we will remember this is another rule of inference for propositional logic, and it says that whenever P implies Q and Q implies R are true, then P implies R is also true. And we have seen modus ponens also. It says that whenever P and P implies Q are true, then Q is also true. So now we are having two rules of inferences for propositional logic, and we can say that if our argument is either in this form or in this form, then using these two rules of inferences we can determine the validity of given argument or argument form. All we have to remember is these two rules of inferences. So we have similar other rules of inferences for propositional logic, and we will continue with these rules of inferences in upcoming lectures, and we will see another way of determining the validity of argument without using truth table. Here they have specified that using truth table we have to determine the validity of given argument form. Therefore, we have used truth table here, and this question was asked in GTU Winter 2024 exam. So remember these two rules of inferences, and we will see another rules of inferences in next lecture. Thanks for watching.